Today we are going to see another algorithm, which is a probabilistic algorithm basically. And this
Okay.
area of machine learning is also very famous and most overlapping area with other models also. Why I am saying so? Like Bayesian, this Bayesian term you will hear a lot. I mean, uh, more or less in different field, maybe in speech processing, maybe in neural networks, maybe in some statistical kind of thing. So this Bayesian learning is very important and it's very much. Okay, so so that's what I was saying that Naive Bayes is one of the algorithm. This Bayesian learning is basically one of the area, uh, a famous area of machine learning, where you will be seeing how the probabilistic models can be built. Okay, now if you say probabilistic models means classification or clustering. There are two kinds of things, right? Supervised and unsupervised. Supervised is like classifications, unsupervised is like clustering, right? So both the things, but with some probability, like probability based classification. Like till now, whatever classification we were doing in SVM, random forest decision tree, KNN, right? In all these algorithms, gradient boosting and all, what we were actually doing is we were saying that this test data is either 1 or 0 through random
Okay.
forest or decision tree, right? So it's
Hmm.
it's from class 0 or class 1. But now
Okay.
the following models which we are going to learn, Naive Bayes and then Gaussian mixture model. Naive Bayes is a supervised classification algorithm which will not say that I am from class A or class B, but it will give you the probability of coming from class A and probability of coming from class B. So you can
Hmm.
say that it is class B with some probability and with class A with some probability. Of course, if you have to classify, then what will you do? The maximum probability class you will choose that as its identified class, isn't it?
In KNN also we saw that the probability
In which
that in KNN model, KNN,
KNN model,
K nearest.
yes, KNN model there was probability kind of thing, but actually it is like it's not like probability, but it is like it is called scoring. It is called as scoring. So scores
Scoring.
you
Okay.
can find in I mean supervised classifications also. I mean the discrete classifiers, whatever they are, like KNN or SVM or some distance based or something you can logistic regression, right? Some function or some evaluation metric you can find that can give you scores, but those are not true probabilities. Like
Okay.
KNN,
Okay.
okay, like in KNN, suppose you say that my K is 10, right? So or 11. Now, if in 11, suppose from if in 11 neighborhood you found that 8 neighbors are of same class and 3 are of say B class. So A1 by 8 by 11 probability you can say 8 by 11 or say 80% score, right? Uh, but those are like count based frequency you have generated, na? Like total 11 were there, so 8 was this, so you can say that this is the probability kind of thing, right? But truly it's not probabilistic, it's like counting, the one which counts more. But what here I am talking about is the models which I am talking about is Naive Bayes and maybe Gaussian mixture model. Those are based on some probability, like this
Okay.
Gaussian probability maybe, or maybe the mathematical probability which we calculate, like if you have 5 balls, red balls, and 5 black balls, and then you randomly pick up a ball, then what will be the probability of getting a black ball or getting a red ball? So something like
Yes.
this we used to solve in our 10th or 12th school days, right? So,
Yes.
so such kind of frequency based, I mean, probabilistic models you can use, or there are others also. We will talk about in detail because Bayesian learning is probability based, but the probability based basis is not that straight. There are few terminologies like posterior probability, prior probability, likelihood. Those terminologies are very important when anyone will talk about Bayesian learning. So whenever you hear Bayesian learning, you will definitely see people talking about likelihood, prior, and prior likelihood, and that posterior probability and all those stuff. So those things we will look into. But what just want to give you as an overview is that now we are going to learn two models. One is neighbors and one is Gaussian mixture model. We will also see one short short project or short application kind of thing for both naive Bayes and Gaussian mixture model, right? So, but yeah, but what I mean to say is these models are like probabilistic models. Now, coming to the model. So this was the background I just wanted to give you so that we should be know we should be aware of that what we are going to start for next few sessions maybe. So now now coming to this naive Bayes model, okay. So first of all, you must know that what is Bayes rule, Bayes theorem. Have you heard of this Bayes theorem?
Bayes theorem.
Yeah, Bayes theorem is one of the popular theorem which we have studied in our school days also, and it's a very famous theorem. If you search it on maybe Google or something, you will find it easily. See,
I can't see your screen.
okay,
Okay.
you can see my screen.
Oh, yeah, yeah.
Okay. So anyway, I was just on the second slide only, and here is the Bayes theorem Wikipedia, where it will tell you what is Bayes theorem. See, this is Bayes theorem. Okay,
Yeah, yeah. Yes, yes.
you might be aware of this theorem. Like
Yes.
says it says like if you want to calculate the probability of A, some event A, like drawing a ball or something, given that this event B has occurred. The B has occurred. The B has already occurred. This event has already occurred. So it's like this first time you roll a dice, you know that it is 6. Now what is the probability that you will get again a 6 or again a say 1? So B, this event has occurred, and for this you have to find out. So there is a direct mathematical formula for that. That is P probability of B given A, okay, upon probability of B and into probability of A. Okay, so
Okay.
if you see this formula,
Mm-hmm.
that's the same formula, right? So basically, okay, now in this is what, this is probability of
So,
event A, simple independent probability of event A. This one is probability of B,
B.
probability of B, event B, and What is the probability of, and what is this? Probability of, if the B event probability you have to calculate. So probability of B if A has happened. Okay. Now this is something like probability of B. This is also called as likelihood.
Yes. Yes.
And this is, which we want to calculate, is called as posterior probability. Okay. This is posterior probability, this is likelihood, this is probability of event A, this is probability of event B. Okay. Now, and this is also sometimes called as prior probability. Prior probability because this is a probability of event A. But right now I am talking in terms of event A and event B, which may not make much sense. But this is a Bayes theorem, and I will turn this Bayes theorem into Bayes classifier. You just wait and watch. I will make the same theorem in terms of Bayes classifier, which will classify any test data into some class. We will see the examples also. We will see a demo example on that also. Okay. But you remember this. Right now I am talking in terms of event and all. When I will come to the naive-Bayes model, actual explaining naive-Bayes, then I will talk about data, what training data you have, and what are the classes in which you want to classify. So when you will talk on those terms, the same equations will become different and data dependent. So let us move ahead. Okay, so this is like a simple, these slides are like nothing but simple classification problem. What is that? What is a classification problem? Training data. You have some training data and you have a goal. A goal is to predict the class. Okay. Yeah. So
Okay.
this Bayes rule is now I am using it as a naive-Bayes classifier basically. The same algorithm, the same AB has now I have turned into H and D kind of thing, right? Now I will tell you what is what. See, the D here is data. H here is hypothesis. What is H?
Hypothesis.
Hypothesis. Now this is called as probability of data. Now what will be the probability of data? Probability of data is nothing. It's a constant thing, right? Probability of data is a constant thing. Now this is what probability of just H. So just probability of hypothesis. It is called as prior probability. Why prior probability? Because it is like without seeing any data, what is the probability that something is, say just an example I am asking. Suppose in a sentence I have to tell what is the sentiment, whether the text has been written in a positive sentiments or a negative sentiment. So sentiment analysis I have to do, suppose. Now without saying data, what is the probability of coming positive and or negative? What is the probability that some text data will be positive or some text data will be negative without any prior knowledge? I mean without
I,
any data. 50-50, isn't it?
yes. Yes.
Suppose I
Yes.
say that I have a text, what will be the probability of, suppose I toss a coin, what will be the probability of head and tail?
50
So
50.
it's 50-50. But if you
Yes.
know the data, suppose you have a statistics of last 10 tossing, Like you toss the coin every hour and you keep the record. And if suppose, assume, I'm just saying in a hypothetical situation, suppose you are tossing coin every hour and every time you are getting head. So say after
Yes.
100 attempts, when again you are tossing coin, and you know that from your past history, from past data, you know that out of 100 times, 90 times that coin gives you head only, right?
Yeah.
So then after even 101st time when you are going to toss and somebody asks that what is the probability that it will be a head, then you cannot say 50-50. Then it will be like based on your historical data, you will say it's 90-10. Because in past also 90 numbers of time it was coming head, and that was not random. You understand what
Okay.
I'm trying to say?
Yes. Yes.
So if you have a past historical data, then you can say your probability, some change in probability. But if you don't have any past historical data, then it is 50-50 kind of thing, right? And that is what I wanted to tell you. This probability, PH, prior probability, is like without seeing any data. 50-50 probability. Without seeing any data. Okay? And
Okay.
yeah, and this thing is called as likelihood. Now, what is this likelihood? Probability of the data if the hypothesis H is true. This is like saying that what is the probability of data D that it comes from hypothesis H. What is the probability of the data D that it is coming from class H? What is the probability of this particular text data that it is coming from positive sentiment? So that will be like probability of this data given the model, given the class. What is the probability of the data given the class? That is called as likelihood. Okay. So I hope these terminologies are clear to you. This is likelihood, this is prior probability, this is data. This is usually constant, right? Because what is the probability of data? Data is like constant only, na? There is
Yes.
no probability of data. But yeah, this probability you can calculate from historical data. This, of course, you can calculate from historical data. And what do you want to predict basically? You want to predict that what is the probability of class positive, right? What is the probability of class, uh, say, negative H, given data D, given data D. So whatever is the probability of hypothesis given data D, that is called as posterior probability. Okay. Why posterior probability? Because you are seeing the data and then you are saying the probability. See, in here, this is called as posterior probability. Why? Because you are seeing the data. Given the data, you are trying to calculate a hypothesis H. Does it make sense? So,
Yeah.
other than that, you can read from here also how these things has come. What is P of H? What is P of d by H? What is P of D? What is P of H by D? H by D, this one is the posterior probability. Okay. Now we have discussed enough about the Bayes theorem in terms of data and hypotheses, isn't it? Now we will move ahead and we will see how do naive Bayes, what does naive Bayes actually do? Okay, I mean, what does naive Bayes do in order to get this thing? Okay, so so basically naive Bayes will calculate the probability of positive class also and negative class also, isn't it? I mean, the naive Bayes will calculate that for say given text, it will calculate that what is the probability of positive class given that sentence, given that data. And similarly, it will try to calculate what is the probability. Just remember, see, these are the probabilistic values. These are not discrete values. That is why they are called probabilistic models. So now, given a situation, I will tell you. Like I will give you an example. Suppose, can you see this paint?
Yes.
Okay. So suppose I have some data D1 for positive sentiment or positive sentiment, and I have some data D2 for negative sentiment. Okay. Now you see this positive sentiment and negative sentiment, right? What here I want to tell you is, if I have to calculate, given a text, I have to calculate whether it is going to be a positive sentiment or a negative sentiment. Are you understanding the funda of positive sentiment and negative sentiment? Positive sentiments are like the movie was good, right? Negative sentiment like is like I didn't like the movie much, right? So it's like that. So if I have to calculate for a text data, textual data, I have to calculate whether it is positive sentiment or negative sentiment. So I will calculate two things. I will calculate what is the probability of positive sentiments given the text data. The text data is like say I went movie and liked it. So what is the probability of this plus class given the data equal to, let's say this sentence is, I am denoting it by D. So it will be equal to what is the probability of the data that it is coming from positive sentiment into what is the probability of positive sentiment class equal to right. Similarly, I will calculate the probability of negative sentiment for the same sentence, right? And then this is
Okay.
like, yeah, and then this is like probability of data given negative sentiment into what is the probability of class negative
Negative.
sentiment divided by probability of data.
D.
This both things you will calculate. Given the data D, given the sentence, you are calculating whether it is positive or negative. How are you calculating? How are you getting this value? Through this. Given the probability of, I mean, what is the probability of data given positive sentiment into, so now what is the probability of data will be like constant only, so you can remove them, and this is also like 0.5 only, both the classes, because the prior probability, who knows what is it, positive or negative, so we will keep it half. So everything depends on now this, because these are equal, These are like the same thing. So the difference is lies in this. This is called as likelihood. Likely.
Likelihood.
Okay. So what is the probability of particular text given the sentiment? So like this I will do. Now let us say this value will come out to be 0.66 and this came out to be 0.38. Let us say. So now you can say that the sentence seems to be more positive with a probability of 66%. And you can say that this is negative. I mean, the, so whatever the sentence we have given is with a positive sentiment or with a probability of 66%, and it do have some negativity also maybe of 38%. So it's like a probabilistic model that what is the probability of coming from class A or B, right? So whichever probability will win, I will consider that, isn't it? So
Yes,
like
yes.
this, you do naive Bayes algorithm. You apply naive Bayes classifier and see that which class got maximum probability. That class is going to win. Okay. Okay. These are just for technology. So so this approach which I have shown you in in paint. In paint I showed you, right? In paint I showed you that how in paint I showed you that how how to if you have two class or three class, how to calculate the accuracies of a class given that data, and then how do you choose that which class I have to identify, which hypothesis I have to choose. So whatever maximum likelihood is coming, right? So that is the funda here, which is called also which is a very famous terminology called as maximum likelihood. I will choose that class which will have maximum likelihood. Okay, so it goes like that. Naive Bayes assumption, yeah, naive Bayes assumption. I will tell you, it is one of the important thing. What it assumes is all the features are independent. Like whatever features you are choosing, like in Irish dataset, how many features we had? Four features, right? Petal length, petal width, sepal length, sepal width. Similarly, that is just an example. I'm not uh, putting Irish dataset into naive Bayes, but I'm for just for reminding you what feature is. I am just telling that, yeah, you have some features every time in your database, right? Data frame or whatever you call it. So like IE dataset had four features. So similarly, whatever number of features are there in text classification or in NLP also, there are applications where you have say 100 features, 200, 500 features. So makes an assumption that all those features has to be independent. When you are independent, basically you can get multiplied, right? If you are dependent, then it is tough to calculate the probability. That is why an assumption is usually taken. Okay, so that if you have A1, A2, A3, A4 till 80 features, so you can just keep like this, right? Whatever your data is. Can you this is okay with you, na? Right? This is like probability of the data
Data set.
likelihood given the hypothesis, and the data is basically t dimensional. So you have t features. You have A1, A2, A3, A4 like this till 80, something like this. Okay. and when we will calculate the probability, this product will come, because it is like this: probability of A 1 into probability of um, whatever it is, probability of A2 into probability of A3 into probability of A4 into probability of something like this. So these all are multiplied. Okay. So that is why this naive-Bayes assumption, they say that is there. Okay. Now what we are going to do, we will maybe see an example. Now this will definitely, I suppose, clear your doubt, and it will, it's a very good illustration or whatever you call it for naive-Bayes. So in this particular example, you will see how naive-Bayes classifier works. Okay. Now this is some historical data which you have. This is some historical data which you have. Okay. Now what is this historical data, by the way? This data is like, you have chills, you have runny nose, you have headache, you have fever, and based on these four features, you have to predict whether you have flu or not. Flu means fever. I mean, whatever flu, like, what do you say? Like any kind of flu, maybe let's say malaria or something, right? So depending upon the four features, chills, runny nose, headache, and fever. Like this is a very small example, just having 8, 9, data points. In real life, you may get 1,000 or 2,000 data points of 10,000 data such data points. Okay. And yeah, so this is just an example to illustrate naive-Bayes. So you see, you have four features, and you have a class which says that it has flu or not flu, right? So and what is this? This is your test,
Test. Okay.
and this is your train. So given that chills was Y, given that runny nose was no runny nose was there, given that the headache was mild, and given that the fever was not there, whether the guy will have flu or not, you have to predict. And this is the already predicted training data. Got it? Now let us do some calculation over this. Okay, let us do some calculation. Okay, you ready? See. Now here what I have to predict, first of all, you should understand. What do you need to predict? So basically we want to predict that whether the guy has flu or no flu.
Or not.
Right. So
Yes.
basically
Yes.
there are two classes now. One is flu equal to Y and flu equal to no. So let us see. So as I told you in the sentiment analysis case, that positive negative one, similarly I am again telling you, first we will calculate, first what we will do, we will calculate the posterior probability of this. Like what is the probability that flu was there given the data. So what will be the probability? Tell me. Probability will be probability of now data given the flu, probability of
Data given the flu.
data given that there is flu into probability of flu, right? flu equal to y divided by probability of data, right? So this is a typical thing which you should calculate, right? So we will see how we are going to calculate this. Okay. So what is the probability of first you see what is the probability of y flu equal to y? See how many times flu equal to y is there?
3,
In here in the
4,
training data, how many times flu equal to y was there?
5 times.
5 times. And total how many are there? 8.
8.
Right? So
Yeah.
so I can say 5 by 8. 5 by 8 times historically I can have flu. Right? So what is the value 5 by 8? Is it 6 to 5?
65. Wow.
Right. So 65 has come here. Then you go and check for each of the probability. Like what is the probability now likelihood? What is the probability of data given flu? So what is the probability that chills was there given that it was a flu? Likelihood I am going to calculate, right? So given that it was flu are how many cases? 5, right?
5. Yeah.
So it's already given that it has flu. Now given that it has flu, how many had actually chills?
2, 3.
3. So basically 3 by 5. So basically zero point 0.6, right? I will
Okay.
write
Yeah.
here 0.6. 3 by 5, right? Now runny nose, 4 by 5, right? Runny nose is almost every time there, right?
Okay. Yeah. Yeah.
So it is 4 by 5,
5, 5.
which makes it 0.8.
Headache.
Right. Now, if you see headache, right? So, okay. So, and you have to also take this into account, this testing data, right? So, if you see the test data, uh, test data, I have to predict flu for chills equal to y, right? So, chills equal to y was 3 by 5 times. Now you have to check for runny nose equal to n. So I did this wrong. I calculated it for y, but actually you have to predict for that it has no runny nose. So no runny nose is just one time, right? When
Okay.
it had flu and runny nose was not there. So it is going to be 1 by 2 actually. Then headache mild. Now mild headache, how many times you had? 3. Out of these 3, how
Yeah.
many times you had flu actually? 1 time.
1, 2.
One time, right? Sorry, 2 time. So
2
basically
times.
2 by 5.
3.
5 times you had flu.
Okay. 5 times. Okay.
Yeah. So that will be like zero point 0.4, right?
Yeah.
We will also see the results. See 0 0.6, 0 0.2, 0 0.4, right? Now fever equal to n. Fever n is how many times? During flu. 1, just one time.
One,
So
just one.
this will be like 1 by 5. So that will be again 0.2, right? So the upper ones you understood now how it has come.
Yeah, yeah. Yes.
Yeah. Now come to this lower one. That is the probability of data. So probability of data is simple. What is the probability of choice? So 4n and 4y's. So zero point 0.5. What is the
Okay.
probability of runny nose? 3 nose and 5 y's are there. Okay. So so that will be again some 3 by 5. 3 nose are there. Okay, and 5 y's are there. 4, 5, and total is 8 basically. Okay, just let me check what actually it is. So 0.5, 0.37.5, 0.37.0.375 it will come. Let us see. This is 0.5 y, you know, na? Because
Yeah, 50. 4y, 4n.
y is like 4 times and total is 8.
Yes.
So it is like 0.5. Now running nose is like 3 times and
3 times.
it's again 8.
8.
So it will be like 3 by 8. 3 by 8 will be 0.30, 324, 60, 75. That
0.35.
0.375. Then mild headache will be 3 by again 3 by 8. Fever N is again 3 by 8. Okay. So those things have come here. Here. Okay. Similarly, you calculate it for no. Flu equal to no given the data point. This you have to calculate the posterior probability. So you will calculate in the similar manner probability of data, probability of data given flu equal to n. Like earlier I was saying for flu equal to y, now you have to see for flu equal to n. And that you calculate. This will be same because this is like this will be same as this because this is like probability of data only. Na? So
Okay.
so keeping and then this is the class probability. So keeping all this account, you will find that the probability of flu equal to y is 2 to 7. The probability of no flu is 0.67, which means the no-based classifier will predict flu equal to no for the above patient because the value of posterior probability was higher for flu equal to n. Okay. So whatever probability is higher, say in this case, this I will make, I mean, this particular thing I will make as a winner because it has more probability. So it's all the game of probability. Whichever class has more probability, you will say that that particular class will win, right? And you can have, it's not about just 2 classes. You can have 10 classes also. And you can similar way you can keep calculating the probabilities and out of 10 whatever say suppose one of them got 50%, so that's fine, that class will win. Now what I will suggest you is to just like we have done the mathematical thing for this from the table, you just prepare the table for this. I mean from that table, seeing
Okay.
the test set, just check whether this calculation is correct or not. Okay. Once you will check this, you will get a lot of insight about the algorithm also. That is what I am saying. You do this calculation by pen and paper, keeping pen and paper for once. Okay, you will get insight about how things works. And remember, this is not only naive Bayes where this likelihood and posterior probability and prior probability you will hear. You may hear this in all the Bayesian learning kind of stuff. Okay, so I hope now this had made sense to you. So was it
Okay.
good enough? I mean, did you understand this?
Not fully, but I understand a little.
Okay, okay. So not
Maybe we'll
fully
go
means
over.
like what is the basic issue? Like what is the thing which you didn't get?
Can
Like
you go
where
to
is this
the
Bayes theorem coming from? Like the basic thing you are lacking or what?
yes, basic thing? Yeah.
Basic thing only.
This
Okay.
this example I understood
Yeah.
about
Yeah.
few
This
examples and
calculation you
how
understood, na?
the question that I understood.